Well, and the next task from sliding window. So let's check. Okay, so sliding window maximum. So let's see what we need to do here. You are given an array of integer nums. And there is a sliding window of size k. Sorry. Which is moving from the very left to the right. You can only see the k numbers in the window. Each time the sliding window moves right by one position, return the max sliding window. Okay, so we have 1, 3, minus 1, and maximum would be 3. Here again 3, here 5, here 5, then 6 and 7. Okay, so let's try to understand the problem. And to talk about, the problem is quite understandable. So we have our array and sliding window, and we have to find the maximum number from here. So let's think about constraints. Okay, constraints. So we have our nums. As I see we can have like minimum and maximum integers, and actually it doesn't care, it can be any integer. Also array can be any integer. So the main constraint here that k should be less or equal than array length, and let's say array length is equal to 10 in the 6th power. So I think that's the main constraint. Let's think about solutions. And let's try from some brute force solutions. So imagine that we have some sliding window and we have some k that equal to 2, for example. So we have 1 and 2. So first we have also maximum, and it would be 2. Then when we move our slider window by 1, yeah, and here can be also 1, right? And also 1. So we can have duplicates. So when we move by 1, we remove this one and add this one, and we check our maximum. Okay, so we move and check. Okay, so 1 is not maximum, so we are not removing. And yeah, 1, this one is also not maximum. Then we move once again, and we should update our maximum. But we should update our maximum with some other value. So let's say that we have here 2, but here we have 3 and then 2, and here then we should update our maximum with 2. So we should have kind of, I think it should be like not this maximum, but it should be, for example, priority queue. Yeah, we actually can sort every time. Or we can try, like we have 1, 3 in our priority queue, and then we take like maximum from this priority queue. And after this, we go forward. Yeah, so the brute force solution would be actually like to have n over k. So k can be n squared, so like 2 loops. Time complexity would be of n squared, and space complexity would be constant. So it's first solution. Let's think about more optimal solution. So we cannot sort here because then we lose a sequential thing, but we can have this PQ actually. But in this PQ it's hard to remove some elements, right? So we have 1, 3. We have 1, 3. Could be max PQ and also min PQ, like 3, 1. So we can maybe handle like min PQ and max PQ. And when we move 1, for example, when we move, then we should remove this 1. Okay, so I think that maybe we can have only one PQ, and in this PQ we will store like index and value. And then we will have a set of indexes that already, we are already not considering actually. Yeah. So for example, when we move, we add to the set 0. And then every value that would be in our PQ we are not considering from this set. And we also have our int maximum. And this maximum would be actually here. So when we move by 1, we remove this element. And when this element is equal to this maximum, we should update maximum from PQ by checking set. Okay. So in this case, if, for example, every time we will remove our maximum and find the next element, then we have like PQ plus set. In this case, our time complexity would be O of n log n, and space complexity would be O of n. So let's try to implement this solution. So we need result array. So our result array actually, nums length, here we have, for example, 6, 7, 8, right? And we have 6 elements. Yeah. So for example, we have 8. So 8 divided by 3, it would be 2. 2 with something. I don't know, with 4, for example. So this means that our result array would be equal to 8 minus 2, that equal to 6. When we have, for example, 9 elements, so it would be 3. So in this case, our result array it should be also 6, I think. Well, yeah, let's check. So let's say that we have, so here, how many, like 3, 6, 7, 8. Yes, let's say 9. So we have 1, then 2, 3, 4, 5, 6, and 7. Yep, so one more. So if we like take 9 minus 3, with 6 plus 1. 8 minus 3 plus 1. And when we have 10, we divide by 3. It would be 3 and something. So it would be 10 minus 4 plus 1. Here it would be plus 0 because we don't have any divisions in. And here actually then, no, away 4. Yeah, minus 3 plus 1 minus 4, 6, 7, 7. Okay, 1, 2, 3, 4, 5, 6, 7. I think we can delete, right? Like 1, 2, 3, 4, 5, 6, 7, and 8. So if we will take like 10 minus 3 plus 1, then we have 8. Then when we have 9 minus 3 plus 1, then we have 9 minus 6, and here it is 7. Then when we have 8 minus 3 plus 1, so 8 minus 2, it equally 6. Okay. So it would be nums length minus k plus 1. So it's our result array. Then, when we have result array, then we have our priority queue. Priority queue. And we need priority queue with pairs. So we have record, pair, I, and value. So we have our pair queue. New priority queue. Okay. And we have our maximum that by default, let's say nums 0. And we also need set of integer, set new hash set, And in this set, we will add like values that we have to delete, actually. Okay, so now we should do first iteration, and iteration should be like this. Like we have k, so we should take like first k elements. So while k is more than 0, we are putting our PQ, and by default PQ is min heap, but we need max heap, so it will be ij j minus I. So we add nums k minus no, we need to have like counter, let's say like for int I equal to 0, I less than k, I plus plus, and pq, and here new pair, and integer would be this one, and value is actually nums I. And then we update our maximum with PQ top element. So now we have our PQ. So if we take this example, so now our PQ have 3, 1, minus 1. Set is empty. Maximum current is 3. So what do we need to do next? Next, we should go one by one by our iteration, and try to iterate through our array. So how we start? So we should start actually from I that equals to k, and I is less than nums length I plus plus. And now I is equal to minus 3. So if I will take nums k and nums I, so it's equal to minus 3. And here I need to put on my result 0, let's say integer j equal to 0 and j plus plus. Here it should be max. So here I have my minus 3, and I should remove 1 from PQ. So what I'm doing here, I'm add to my set I, because I'm removing it, and I'm check while PQ top is so I take my current. I also should add this to PQ, so I'm adding this value to PQ current, and it will be with index current index. I actually add my minus 3 here. Okay, well, what next? So when I add, when I have my current -3, I add to set not I, because to set I should add something that I remove. So I should make like I minus k. And here I add 0. In PQ I'm adding -3. Okay. And here I have 3 that is equal to 1. 1 is equal to 0. -1 is equal to 2. And -3 is equal to 3. And I'm checking while PQ top, no, here I should check like what elements I'm actually remove, right? So I remove this element. And I check if PQ top while PQ top is not equal, PQ top here is important, I is not equal I minus k, and PQ top and here set contains while PQ top equal to and or set contains PQ top, then I should make like PQ poll. Okay, and after this manipulations, I should add to my result. I should update my max with PQ top and add to my result max, and then return result. Okay, I think it should work something like this. Let's run it. Yeah, we have compilation error on 20. What kind of error we have? Priority queue. Yeah, it should be queue. Okay. Yeah, so priority queue is with, I should check j val minus I val. Okay, so here cannot find top, maybe pick because it's queue. Okay, no. Cannot be converted to int. And if top, cannot find symbol. Okay, pick and val. Here, then pick and val and pick. Let's run it. Here as well, pick I. Okay, accept it and let's submit it. Nice. So we are done. Let's check editorials, solutions, and a quick explanation. All right. Yeah, so actually they're doing kind of the same thing. Okay, thank you very much. And that's all for you.